In this video, we're going to talk about partial fractions. Before we do that, let's review from pre-calculus about partial fraction decomposition. In other words, what are two fractions, or at least two fractions? When you add them up, you'll get this whole fraction right here. In order to do that, you need to find the factors of the denominator. So you get x plus 4 and x minus 1. So this means some number a over x plus 4 plus some number b over x minus 1 should equal to this thing right here. Now we need to find what a and b are. So what we're going to do is we're going to multiply the whole thing by the lowest common denominator, which is x plus 4, x minus 1. So let's multiply the whole thing by LCD. You end up getting 5x plus 5 equals a times x minus 1 plus b times x plus 4. Now this is what we're going to do. We're going to let x equals 1. Because when x equals 1, this whole thing goes to 0. So you'll be able to find what b is. So when x equals 1, you end up getting 10 equals 5b, which means that b is 2. Now we're going to let x equals negative 4. Because when you let x equals negative 4, this will be 0. So you'll be able to find what a is. And you end up getting, when you plug in negative 4 for x, you get negative 15 is negative 5a. So as a result, you get a equals 3. So we found a and b. So you could rewrite this as 3 and 2. So this is called the partial fraction decomposition, when you are breaking down the fraction into 2 or more fractions. And now you're going to see why this is so important. Now let's say you want to find the integral of this. So the integral of this will be same thing as integral of this, integral of that. So what's the integral of that? Well, you could take out the 3 out. So it will be 3 natural log of absolute value of x plus 4. And here you could take the 2 out. It will be natural log of absolute value of x minus 1 plus c. Let's take a look at this example. You have to find the integral of this. Now here's a hint. You use partial fractions when the degree, the numerator and denominator are both polynomials, and the degree of the denominator is 1 higher than the degree of the top, or the degree of the denominator has to be higher than the degree on the top. If they're both the same, or if the degree on the top is higher, then you got to do the long division, which we will talk about later. So first, in order to do this, we have to do partial fraction decomposition. So we need to find x minus 13 over, if you factor it out, you get 2x and x minus 3 here and then negative 1. You need to find out a over 2x minus 1 plus b over x minus 3. And we got to find a and b. So we're going to use a similar method. We're going to multiply by the LCD, which is 2x minus 1 times x minus 3. So when you multiply it by LCD, you'll end up getting x minus 13 equals a times x minus 3 plus b times 2x minus 1. So first, we're going to let x equals 3. So when x equals 3, you get negative 10 is, that goes to 0, 7b. So b is, I'm sorry, it should be 5. So b is negative 2. Now we got to find what a is. We found b. So we're going to let x equals, how do you make that equal to a 0? That's when x equals 1/2. So you get 1/2 minus 13 is a times 1/2 minus 3 plus 0. So you end up getting negative 25 over 2 is a times negative 5 over 2. Multiply by everything by 2, you get negative 25 equals negative 5a. And a is 5. So we found a and b. So instead of, so in order to find the integer of this, you take the integer of that, don't forget the x. So this will be 5 integral of dx over 2x minus 1. I'm going to take out the negative 2. 1 over x minus 3 dx. So here, you need to have a u equals 2x minus 1. And what is du? It's 2 dx. And you don't have dx. I mean, you don't need 2. So dx becomes d over 2. So you end up getting 5 over 2 natural log of 2x minus 1 for this portion. Using the similar method, actually this is easier because just x minus 3. And you end up getting minus 2 natural log of x minus 3 and then plus c. So that will be your final answer. Unless you use the property of natural log, that could become exponent. And when you have natural log of a minus natural log of b, don't forget that you could put it as natural log of a over b. So sometimes they go further and simplify using properties of natural log. Now we have this example here. Notice the degree on the bottom and the top. The degree on the numerator is bigger than the top. So whenever the degree are equal, or the degree of the numerator is greater than the denominator, you have to do the long division. You have to simplify first. So let's do the long division. We got 3x to the 4 plus 0x cubed plus 0x squared plus 0x plus 1. Then you're going to divide that by x squared minus 1. So you need 3x, you need 3x squared. So you multiply that, you get 3x to the 4 minus 3x squared. Now you have to change the sign and add them up. So you end up getting 0x cubed, which is 0. And then you get 3x squared plus 0x plus 1. So x squared times what is 3x squared? That's plus 3. So you end up getting 3x squared minus 3. So you have to change the sign, add them up, you get 4. So 4 is our remainder. So you could rewrite that as 3x squared plus 3 plus 4 over x squared minus 1. So when you actually find the an integral of that, you actually find the integral of this. And this portion is easy to find the integral because this becomes x cubed plus 3x. But this portion, you need a partial fraction. So let's do decomposition here. I already factored x squared minus 1. So multiplying by the LCD, you end up getting 4 is a x minus 1 plus b x plus 1. So you let x equals 1, you're going to get 4 equals 2b. This means b is 2. What about let x equals negative 1. So 4 is negative 2a. So a is negative 2. So this becomes, your a is negative 2. Your b is 2. Now, we need to find the nth root of this. So this becomes negative 2 natural log of absolute value of x plus 1 plus 2 natural log of absolute value of x minus 1 plus c. Now I'm going to switch this to order. All right, so when I factor out the 2, I get that. Now remember the property of natural log? Natural log of a minus natural log of b could be natural log of a over b. So all we need to do is, in order to finish that up, we've got to put plus 2 natural log of absolute value of x minus 1 over x plus 1, and then plus c. So that will be our final answer right there.